Here we go with number 3 in the set and drift section, page 37 of your student handbook. It says at 1922, your position is latitude 41 degrees, 09.2 degrees north by longitude 71 degrees 40.6 minutes west. You're on a course of 28 degrees per standard magnetic compass at 8.9 knots. 1 hour later, your position is latitude 41 degrees, 17.2 minutes north by 71 degrees, 38.6 minutes west. What was the set and the drift? So again, in these problems, I like to write down true to remind myself to true up the heading. Okay, I write DR or distance and EP for ending position. So if I write all that down, it kind of tells me the steps to solving the problem. So the first thing I got to do is find the true course. So this is problem number 3. The true course or the compass course is 28 degrees. So if I've got 28 degrees given in compass, I've got to take that from compass to true. So I'm going to use that TVMDC formula, okay, that I've used before. And the 28 degrees is in compass, so I've got to work from compass to true. So when I'm going from compass to true, what do I do with those errors? I subtract westerly errors and I add easterly errors. So I'm going to find the deviation for 28 degrees. Okay, 28 degrees, pretty close to 30 degrees, so I'm going to use 3 east. And if I have an easterly deviation, I'm going to be adding. So that gives me 31 degrees. Okay, and if I have variation on this chart, which I get from the compass rose, okay, I've got the outer ring, which is true. I've got the inner ring, which is magnetic. So the difference is 15 degrees west. So I'm going to write 15 west. And if I have a westerly error, what am I going to do? I'm going to subtract. So 31 minus 15 would be 16 degrees. So my true course is 16 degrees. Okay, I'll make a note to myself. All right, 16 degrees. I'll make a note up here. Okay. The DR, the distance, is the place, the distance I'll travel and the time that I'm out there. Well, again, it says I'm going 8.9 knots for 1 hour, so I'm going to travel 8.9 miles, 8.9 miles, okay? And my ending position is that position that they give me at the end of the problem, so I'll write that down. It's 41 degrees, 17.2 north by 71 degrees, 38.6 west. Okay, so I've got that information. I can plot the starting point on my chart, which I've already done. It's right here. You'll find that in these problems, most of the problems start with the ending position from the previous problem, just to help you speed this process along. So I've got to draw a line from my starting point in the direction that I'm going true. I can't draw in compass, okay? I always plot in true. So the true course is 16 degrees. So I'm going to start by finding 16 degrees. And once I've got 16 degrees, there's 15, there is 16. Okay, so 16 degrees. I'm going to bring my parallel rules down to my starting point, okay, which is right there. And I'm just going to draw a long line from my starting point. Whoops, I just moved it. Let me just come back here again and make sure I'm on 16 degrees. Okay, now I'm back on 16 degrees. Let me make that mark. Okay, now I'm just going to draw a long line in the direction of 16 degrees. Okay, so I've got that line on the chart. I'll just go ahead, I'll kind of leave my parallel rule there for a minute. Now I'm going to mark where I would end up in an hour, my DR. So my dividers don't open to 8.9, so I'm going to say 8.9 divided by 2 is 4.45. So I'm going to open my dividers to 4.45, and then I'm just going to double check that I end up at 8.9. Okay, I've got a couple sets of dividers. So I'm looking for 8.9. So there's 4.45. So there's 4, there's 5, there's 4.5. So 4.45 is right there. Okay, let's see if I end up at 8.5. Not quite, or 8.9, I'm sorry, yep, 8.9, yep, that's what I was looking for, 8.9, and I'm at 8.9. So I know that I'm good. So now I'm going to start on my, I'm going to walk that off. There's 4.5, and another 4.5 gives me 8.9. So there I have my DR, which I will put a half circle around just to remind myself. Okay, so that's where I should be. Now I'm going to plot my ending position. So 4117.2, okay, 15, 16, 17.2 is up here, and 7138.6, so 71, 30, 31, 35, 36, 37, 38.6. So it's going to be somewhere in this ballpark. All right, so now that I know where it is, I'm going to come down. So again, 4117.2. So I'm lining up on a line of latitude, and I'm coming down to 17.2. So 15, 16, 17. Now I've got to start over this way. Let's see if I can get that right. Okay, so again, 4117.2. So here's 15, 16, 17.1.2. Okay, so 4117.2. Okay, 15, 16, 17.2. I like that. And 38.6. So 38.6. 35, 36, 37, 38.6. So I'm going to draw my line over here. I try not to draw really big lines because I'm going to have to erase them later. Okay, and the other half of that was 38.6. So you can do this in a variety of ways. This is a good way to do it. 40, so here's 39, so 38.5.6. Okay, so again, I'm just going to draw a line where they intersect instead of a long line. Okay, so here's my DR, the line that I should be on with the DR marked where I would be in an hour, and here's where I actually ended up. So what is the current doing? It's setting me in this direction. So I want to know what that direction is because set means direction of the current. So I'm simply going to put my parallel rulers between the two places. Okay, and try to be as accurate as you can because just a little bit of difference can yield you a pretty big difference in the answer. So again, the current is setting me in that direction. I should be on the line, but I'm being pushed to the southwest of my line. So I'm going to read the southwest side of the compass, and I'm going to mark it. Okay, and then I'm going to read that number. It looks like about 232. Okay, looks like about 232. So I'm going to write that down. Okay, 232. 232 degrees, and then I'm going to measure the speed and distance, okay, well, I'm going to measure the distance in order to determine the speed. So again, the second half of the question was, what is the drift? It said set and drift. Drift means the speed of the current, and the formula for speed we know to be distance, meaning the distance between the DR and where I ended up, the ending position, okay, divided by the time we were out there. In this case, we were out there for 1 hour, so whatever this distance is divided by 1 is going to give me the speed of the current. So I have 1.1, so 1.1 divided by an hour, it would give me a speed of 1.1 knots. So the answer I came up with was 232 at 1.1 knots. This is question number 3 in our books. So we came up with A. Okay, so I'm off by 3 degrees. I got this distance right, or the speed correct, but don't choose your answer because the speed matches. You know, the difference between 1 knot and 1.1 knot is quite small, but the difference between 235 and 62 is quite large, okay, or 247. So always choose the answer based on the set, the direction, okay? You should be solidly closer to one answer. 232 is only 3 degrees away from this answer, but it's a long way away from all these other answers, okay? So number 3, you should have A for your answer, okay?